How do homologous and analogous structures differ for GED evolution? Imagine two animals that look similar but are not closely related. How can that be? Well, today we're going to find out how scientists tell the difference between structures that show common ancestry and those that don't. Homologous structures are like family heirlooms passed down from a shared ancestor. They look different because they have adapted to different jobs, but their bones or basic design are similar. For example, the arm of a human, the wing of a bat, and the flipper of a whale all have similar bone arrangements. Even though they are used for different things like grasping, flying, or swimming, their underlying structure shows they all came from a common ancestor with a basic limb. This tells us that these species are related and have evolved over time by changing the same basic parts. Now let's look at analogous structures. These are like similar tools that different people invent independently. They look alike or do the same job but didn't come from a shared ancestor. Instead, they evolved separately because the species faced similar challenges. Think about bird wings and insect wings. Both help with flying, but their internal parts are very different. Bird wings have bones and feathers, while insect wings are made of a different material and have a different structure. The same goes for fish fins and dolphin fins. They both help in swimming, but they come from very different evolutionary paths. So, the main difference is that homologous structures come from a common ancestor and show how species have changed over time. They reveal the shared history of life. On the other hand, analogous structures develop because species face similar environments and need similar solutions, even if they are not related. They show how nature can find similar answers to survival problems in different ways. Understanding these differences helps us see how evolution works. Homologous structures tell us about the family tree of life, showing connections between species. Analogous structures show how different species can develop similar features independently because they live in similar environments. This is a key idea in natural selection, where species adapt to their surroundings in ways that suit them best. So, whether it's a bone in a limb or a wing that helps a creature fly, these structures help scientists understand the story of how life has changed and adapted through time.